Welcome back to the Explainer. Today, we're going to build out that essential toolkit for anyone starting out in software quality assurance. We're breaking down the core types of testing you'll be dealing with pretty much every single day.
All right, picture this. A developer just handed you a brand new software build. So what's the very first thing you do? Before you start digging around for complicated bugs, you have to do a critical first pass check. And this is where that foundational testing vocabulary really comes into play. Okay, before you even think about getting into the nitty-gritty, there's one massive question you gotta answer. Is this thing even stable enough to test? And that's where two key ideas come in: smoke and sanity testing.
So, smoke testing. Think of it like a first aid check for the software. Can it even start up? Can you log in? You know, the absolute basics. That's why people also call it build verification testing. I mean, if it fails this, you just send it right back. There's no point in testing a patient that doesn't have a pulse, right?
Okay, so let's say the build passes the smoke test. It's considered, well, basically stable. Now you might run a sanity test. This one's a little more focused. You're just checking to see if the main features, the big stuff like search or checkout, are still acting rationally, still sane after a recent little tweak.
So let's really nail down the difference here. Smoke testing is basically the bouncer at the door, asking, are you even stable enough to come inside and be tested? But sanity testing? That happens once you're already in the club. It's asking, okay, are the main attractions still working like they should? All right, so the build's stable. You get to work. And you find a bug. You write it up, report it, and pretty soon the developer sends you a new build with a supposed fix. So, now what?
This whole cycle? This is the daily grind, the absolute bread and butter for any QA engineer. But that last step, verification needed, it's not just one thing. It actually splits off into two of the most important and, honestly, most confused types of testing out there.
And there you have it. The two big questions that define the next phase. Did the fix actually work? And, maybe more importantly, did it break anything else in the process? First up, retesting. The key thing to remember here is that retesting is totally laser-focused. You are running the exact same steps that made the bug appear in the first place. Your only goal is to answer one simple question. Is that specific bug I reported now fixed? It's a simple yes or no. And then you have regression testing. Now this is the complete opposite. We're not using a laser pointer anymore, we're using a floodlight. You're looking for any weird unintended side effects. You're hunting for regressions, places where the quality has actually gone backwards. The fix might have worked, sure, but did it mess something up in a totally different corner of the app? And this analogy just hits the nail on the head. You wouldn't think fixing a kitchen faucet would have anything to do with the shower upstairs, but in a really complex system of plumbing or, code, one change can have ripple effects you'd never expect. You have to check. Okay, listen up, because this right here is a classic interview question. The difference is super simple, but it's absolutely vital. Retesting is all about confirmation. You're confirming the fix. Regression testing is all about protection. You're protecting the rest of the app from new problems. So we've talked about scripted tests, right? But what about the really sneaky bugs, the ones that nobody ever thought to write a test case for? Well, to find those, we have to go off-road, off-script, and this is where things get interesting. See, this is where you really see testing become less of a rigid science and more of a creative art. Finding these kinds of hidden bugs, it really depends on the tester's own skill, their intuition, their experience, and yes, sometimes just a little bit of pure chaotic randomness. So you can kind of think about these three methods on a spectrum of knowledge and chaos. At one end, you have exploratory testing. This takes a lot of experience. You're learning how the app works and trying to find bugs at the very same time. Then there's ad hoc testing. It's a bit more mischievous, the basics, and you're intentionally trying to break things with weird inputs. And at the far end of the spectrum, you've got monkey testing, pure chaos. No knowledge needed. It's literally like letting a monkey bang on the keyboard to see if anything crashes. But, all this freedom, it definitely comes with some big risks. The number one problem? If you don't have a clear document telling you how something is supposed to work, you might report something as a bug that's actually a feature.
And oh man, if you find a bug by just randomly clicking around, trying to remember the exact steps to reproduce it can be an absolute nightmare. Okay, for our last section, let's zoom out and look at the fundamental philosophy, the 2 core principles that are behind literally every single test you will ever run. First, there's positive testing. This is all about answering the most basic question. Does the software do what it's supposed to do when a user does everything right? We call this the happy path. It's the ideal perfect world scenario. But when do users ever do everything perfectly, right? That's where negative testing comes in. Here, the goal isn't just to see if the app breaks when you give it bad data. The real goal is to see if it breaks gracefully. Does it give you a helpful error message? Or does it just totally crash and burn?
In this example just makes it crystal clear. Putting a number where a number should be, that's positive testing. Putting letters where a number should be, that's negative testing. It's that simple. One test to check the rules and another to check what happens when you break them. A really solid application has to be great at handling both. And at the end of the day, that's what this is all about, isn't it? Every one of these tests we've talked about, from that initial smoke test to the big regression suite, from the happy path to the negative cases, they're all just tools in your toolkit. And you're using them to build a fortress of quality around that software product. Knowing which tool to use and when, that's the real skill. So I'll leave you with this one final thought to chew on. Is the real goal of testing to confirm the software works or to prove that it breaks? It's a tricky one, and it really gets to the very heart of the whole QA mindset. Are you a builder or are you a breaker? The truth is, you kind of have to be both. Thanks for joining this explainer.